That's right. So today we're going to learn the FOIL method, everybody. So what I want you guys to do is I want you to read this. It says the FOIL method is a simple way of remembering how to multiply two binomials together. It's just another form of the distributive process. So here we go. If you would please write this problem in your journal. 2x plus 5, parentheses, x plus 5. Write it down, just like that. Alright, the first thing we're going to do is we're going to multiply the first two numbers of each binomial. What are our first two numbers? 2x times x. So what do you guys think? 2x times x is going to equal 2x squared.
The force is with you, young Skywalker. You're not a Jedi yet.
Alright. That's the first step. Multiply the what? The first two numbers of each binomial. What's the next step? The outside numbers, or the outer numbers. What's the product of the outer numbers? 10x. 10x? I think that's 10x, huh?
Yeah.
He's right.
Do I can? Yes.
Watch this joke. Okay. Alright. Now. Oh, what'd you say? Inner?
Inner and outer.
Oh.
Inside of
What's the inside product?
5x.
5x, alright?
I got a bad feeling about this. I find your lack of faith disturbing.
Alright, and what's the last two numbers?
5
times 5. Alright. So 5 times 5 gets us a 25.
You cannot escape your destiny.
And what's the final thing we have to do after we get it all set up like this? That's right. Now combine the like terms and you're done. Say it again.
2x squared plus 15x plus 25.
I like it right there. R2 approves.
Thank you.
Alright, so that right there is the FOIL method. What we're going to do right now is we are going to go to our first problem dealing with the FOIL method, which is problem number 8. Right there. And we are going to do it a different way. We're not going to use the FOIL method. Well, actually, we'll use the FOIL method on this one, and then we'll do something differently with problem number 10. So if you would, please put problem number 8 into your journal. We're going to practice this. Right now, we're doing the FOIL method. So we're going to do what's called the first, the outside, the inside, and the last. So we're going to do it step by step. Okay? So we're going to start with our first numbers. What are our first numbers right here? X times x, which gets us
X squared.
x squared. Good. Okay. Now I'm going to open up a couple of parentheses right here.
5x.
Okay. What am I going to put right there?
X.
What am I going to put right here?
5.
And together that becomes
5x.
5x. There we go. All right. Then we're going from the outside numbers to the inside numbers. I'm going to open up a couple of different parentheses right here. What number am I going to put there?
3.
Negative 3. Good. Stay closer to the negative. What are we going to put here? X. And that becomes a total of
X squared.
negative.
Negative 3x.
There we go. We always put the coefficient up front. Now, notice, these are what? These are like terms. So we're going to have to combine those together. Okay? And then we finally have our last terms in our binomials. So what are our last terms?
Negative 15.
And 5, good. We get negative 15. So now that we are done, all we do is combine our like terms. We have an x squared. We have 5 minus 3, which is plus 2x minus a 15. Okay? Now I'm going to show you guys a little shortcut here. So follow the hand, see if you guys can see the shortcut. Whenever the coefficient in front of this x is just a 1, and there's just another coefficient in front of this x as a 1, It's super, super fast. You don't have to do the FOIL method. All you have to know is this short little trick. What is 5 minus 3? 2. Boom. What is 5 times negative 3? Negative 15. Okay? That is a short, quick little trick. Now, I'm going to show you guys. We're going to do a quick one real quick. I want you to put on your paper. It won't take long. I'm going to put an x minus 7, x plus 9, and we're not going to do the FOIL method. We're going to do a quick little process. We are simply going to do negative 7 plus 9, and we're going to do negative 7 times 9. Okay? That's all we're going to do. What's negative 7 plus 9? Well, what's 9 minus 7? 2. What's negative 7 times 9? Negative 63. So if I did the FOIL method, my final answer would be x squared plus 2x minus 63. All I do when there's a coefficient of what in front of the x? A 1 and another coefficient of a 1, you can do this shortcut. 9 minus 7 is 2. 9 times negative 7 is negative 63.
What problem is
An example.
that? Okay.
Okay? Alright, I'm gonna do one more. Alright, then I'll pause it. Here we go. Alright, so right now, here's what your final answer is gonna look like, okay? What number do you think is going to go in there if we just use this quick little process? What?
5.
5, very good. What number do you think is gonna go in there?
Hold on. Negative 50.
Alright, so since I put the minus sign, we just put a 50, okay? Why? Because 10 minus 5 is 5. 10 times negative 5 is negative 50, and that's your answer. This is how quick these can happen, alright? Now, what we're going to do next is we're going to go down to, let's see here.
Number 20.
Let's do number 10. We're going to do number 10, then we'll go back and do number 9. Okay? Yeah, but we're going to do something different here. Here's what I'd like you to do. In problem number 10, what I'd like you to do is I would like you guys to make a rectangle. Okay? And we're going to split this rectangle into 4. I didn't do a very good job there. There we go. There. There we go. That's what I want you to build. Okay?
Oh, that's pretty cool.
I want you to build that right there. Okay? Now, you guys see where it says 6x? I want you to put 6x right here. I want you to put negative 1 right here. This x, I want you to put right up here at the top of this rectangle, and that plus 2, I want you to put right there. Now, this might look familiar to something that we've done already, so this is how you can do binomials. Here's how you can multiply binomials. We can multiply the area of each little section. Okay? So right now, I'm just going to put, this is going to be 6x times x, which becomes 6x squared. So that's the area of this little rectangle. Okay? The length and the width of this rectangle is 6x times 2, which gives us a total of 12x. That's the area of that rectangle. Okay? This one's going to be a negative 1 times an x, which is a negative x. That's the area of that rectangle. And last but not least, we have a negative 1 times a 2, which is a negative, that's the area of that rectangle. This might be a very, very easy way. This is kind of this is the FOIL method, but it's not doing with the, it's doing the exact same process. It might be an easier way to organize the information, okay? So what is we're going to take 6x squared. What is 12x minus an x?
11x.
So we can put 11x.
Okay, so minus 2.
There we go. See this right here, it's the same thing. It's the same thing as doing what? First, outer, inner, last. So it's the same process. Okay? You like FOIL method? Some students like this method, some students like this method. Okay? Alright? Alright, so what I'd like us to do, well, you may have done the FOIL method longer, or you may have been, at some point been introduced to it. Okay? But both ways you'll need to know how to do at some point. Okay? Alright, so right now, what I'd like you guys to do in your journal, okay? This is a special product. I want you guys to write a special. This is a special product, okay? This special product is what's known as a difference of squares. Okay? This is a difference of squares. Alright, I just realized something. Some of you are probably laughing at me because that's not how you spell difference. So just realize that. Here we go. Let's difference. There we go. That's much better. Alright, it's not difference. Alright, it's difference of squares. Alright, so here's what I want you guys to do. This is what if you Googled it. Right? What's the difference of squares? This is probably what would show up on Google, right? A squared minus b squared equals a plus b and a minus b. Okay? So this right here, this will eventually, alright, automatically without having to do a whole bunch of work, all I got to do is go, hey, what's negative 4 plus 4? Now, what's negative 4 plus 4? Nope, what's negative 4 plus 4?
0.
That's right, it's 0. So how many x's am I going to have in the middle? 0. Well, what's negative 4 times 4?
Negative 16.
This is a difference of squares. This is a special product. All the x's in the middle cancel each other out. Now I'm going to show it to you, like, just do the FOIL method. I'll show you how easy this is. Ready? X times x is x squared. X times a 4 is 4x. But negative 4 times x is a negative 4x. So that's why they cancel out. So I'm trying to show you the process. What happens with all those? Those are a 0 set. They cancel out to a whole lot of nothing. Okay? And we get x squared minus 16. So I want you, when you guys see this, these are super, super easy to multiply together. Alright? It's called the difference of squares. So let me give you guys a quick little list of what you need to put in your journal of the difference of squares, and then you guys should see the pattern. Here we go. The first one you usually see is x squared minus 1. Then you'll see x squared minus 4. You'll notice, and this is the one that we have. Okay? So I'm going to stop right here at x squared minus 25. Hopefully you guys see that's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and it keeps going on. Okay? But these are the products of these factors. I'm going to have to show you the factors. So the factors of this would be x plus 1 and x minus 1. The factors of this would be x plus 2 and x minus 2. Okay? You guys see the pattern here? Hopefully. So this was our problem, right? We said, hey, what was x plus 4 times x minus 4? And what was our answer? Our answer was that right there. But if I gave you, hey, what's x plus 5 times x minus 5? You would say it's x squared minus 25. Those are all examples of a difference of squares. Okay? All right, so here we go. What we're going to do now is we are going to do, let's see here, 11? All right, let's do 11. Here we go. Let's do 11. All right, what I want you guys to do, you guys go ahead and do 11. All right, come up with an answer for number 11. And I'm going to do, since I only did it one time, I'm going to do the rectangular method instead of the FOIL method. All right, so I'm just going to do the rectangular method one more time and see if you guys like that or not. I prefer the FOIL method because I've done that a lot longer, but I'm just going to set this up. We have 2x and a negative 3. We have a 3x and a 2. All right, we have 2x times 3x. That's a total of 6x squared. Good. Now, right down here, we have 3x times negative 3. Negative 5x. All right, negative 9x. Good. 2x times 2. 4x. Good. And negative 3 times 2. So, now, I will say this. The one benefit of doing this way is you have all of your information organized. All right? I would say if a student did it this way, they're less likely to make an error, then they might miss a step on the FOIL method. They might mess up with one of the negatives. They might, like if they're doing the FOIL method, they might forget to multiply a negative, but if they set it up this way, you see that -3, you want to make sure you put that -3 in. They still might mess it up, but this right here is probably a more organized way. Okay, so we have -9x plus 4x, which gets us to a -5x, good. And then we just put -6 at the end, so that's your final answer. Okay. Now, we're going to do one more problem together. Actually, we'll do two. Let's do a fraction. 19, is that a fraction?
Yes, it does.
All right, let's do number 19. Oh, 20? Here we go. Let's do number 19. All right, we're going to do number 19 the FOIL method way, and we'll do number 20 the rectangular method.
You should kind of let us do number 19.
Okay, I'll go. I'm just going to set it up. You guys go ahead and do number 19 on your own. Okay. Now, by the way, I'm just letting you guys know this is another example of a difference of squares. Because there's a plus and then there's a minus. So good luck. The final answer, here we go. We have a half x times a half x, which is 1/4 x squared. Then we have a half x times a -3/5. Now the numerator times the numerator, that's a -3. Denominator times the denominator is a 10. Okay? Then we do 3/5 times 1/2. Hey, we just did that. That's a positive 3/5 x. Oh, interesting. What happens to all of those? Oh, this is a difference of squares. Okay? And then the last thing we have to do is a positive 3/5 times a -3/5. And that gives us a -9/25. Because 3 times 3 is 9 and 5 times 5 is 25. So our final answer is 1/4 x squared minus 9/25. What was this another example of? Anybody? Difference of squares. One of these examples right there. Okay? And number 1t. So here's what I want you guys to do. We're going to do the rectangular method on this one, okay? Put it right here. Draw a rectangle. And another rectangle. And one more. Right. Oh, that's back here. That's not. There we go. Okay. So what? Now, like this says 1/2 x plus 3/5 squared. This is actually called what's called a sum of squares. This is an example of the sum of squares. If you Googled sum of squares, this is probably what it would say. A plus b squared equals a squared plus 2ab plus b squared. Now this is a harder thing to recognize, but it actually is pretty easy once you get used to it. Okay? So right now we're just going to do 1/2 x, and here we're going to put 3/5. Okay. Right here we're going to put 1/2 x, and we're going to put another 3/5. That's how we set it up. Now, if I do 1/2 of an x times 1/2 of an x, that's still 1/4 x squared. Good. Okay. But if I do 1/2 x times 3/5, that still gets me to 3/10 x. And over here, this would also get me to 3/10 of an x. And this right here would still be the same product at the very end. It's 9/25. What do we have to add together? We have to add those together. And what is 3/10 plus 3/10?
6/20.
Right. 6/10. Remember, that when you're adding fractions, denominator, right? Why are we allowed to add these fractions? Because the denominator is the same. Okay? And that becomes 6. But now, can I reduce that?
Yes.
Right. So that becomes 3/5 x. Okay? So here's going to be your final answer for number 20, right? 1/4 x squared plus 3/5 x plus 9/25. Okay? Now, I'm going to give you guys right now, remember how you guys have in your journal a difference of squares? if you go to the way you put a difference of squares, I'm going to give you guys an example of a sum of squares. All right? Just going to give you 4 examples of a sum of squares. And I want you guys to write this down in your journal. Because this is another special product, sum of squares. Okay? So we're going to start with x plus 1 squared. And then we're going to do x plus 2 squared, x plus 3 squared, and the last example is going to be x plus 4 squared. But this is not going to take us very long to do at all. You just follow along, just plug in what I plug in. And then we'll go over it. So just write everything down first. Just write it down, and then we will go over it. I just want you to see a pattern. Okay. So this is an example of a sum of squares. All right, now that you guys have this written down, we are not going to do the FOIL. Now, could we do the FOIL method on all these? Yes, but we're not going to. All it is x squared, what's 1 plus 1? 2. So, what's 1 times 1?
4. Oh.
Okay. Over here, 2 plus 2? 4. 2 times 2? 4. What are the only 2 numbers that add together and multiply together equal the same number? 2. All right, what's 3 plus 3? 6. 3 times 3.
9.
There you go. These would be, right now, what we're doing, these are all the product. These are all of your answers. Okay? So if I gave you x plus 1 squared, the final answer would be this. If I gave you x plus 2 squared, it would be this. Okay? So what do you guys think the final one right here is here?
X.
Close.
X squared plus 8x plus 16.
There we go. That's.
Say 8x.
I know you were just jumping straight to the 8x, but we were at x squared plus 8x plus 16. Now remember I said you can also do this with negative, so we're just going to do another one right here. I'm going to say x minus 7 squared. Now what am I going to put in parentheses? So if I say x minus 7 in parentheses squared, what's going to go right here? X minus 7n. There we go. All right, and so now we do the same process. It's x squared, but what's negative 7 plus negative 7? No. Negative 14. But what is a negative times a negative?
49.
Positive 49, okay? So what do you still do? You still add those together to get the middle term, and you multiply them together to get the last term. So that's the process of those, okay? So, before we have 3 minutes left, what I'd like us to do right now is go to the very final problem, which is a star-related problem. We're going to the very, very, very final problem that looks so intimidating, okay?
What, question 19?
All right?
Ready, go.
Okay? Now, what I'd like you guys to do, you see how it says this times this? Now, you could use the FOIL method, but you'd have to do 3 terms. So here's it's not that bad. So what I'd like you guys to do, see where it says negative 4h right here? I want you guys to put the negative 4h right there. Where it says 3, I want you to put 3. And where this says h squared, I want you to write h squared. Okay? Where this says 9h, I want you to put a 9h right here. And where you have the minus 1, I want you to put a minus 1 right there. Now what we're going to do is I want you guys, all right, in this next minute, I want you to come up with all the products for how many rectangles? 1, 2, 3, 4, 5, 6. All right, so go do that. All right, everybody, you guys should have gotten right here. I'm going to put it answer in green. That should be negative 4h cubed. Come on, 4 break up. 3. All right, this right here is negative 36h squared. This right here is positive 4h. Then over here we have 3h squared. Here we have 27h, and at the very end we have negative 3. So right now we're going to lead out with negative 4h cubed. We have to add those together, so that's negative 33h squared. Hold on, quiet please real quick. I'm highlighting the things that are like terms. See those are like terms? And these right here are also like terms, so I have to add those together to get a total of
Plus
31h, and then we have a minus 3. Alright? So what would be the final answer for this particular question? Right? That's right there. There you go. Y'all have a good day.